because I know I cleaned it up. I have no idea why that happened. I hope it doesn't do it again. So this is x squared plus x and minus 2, and I will factor into x minus 1 and x plus 2. What is it? So negative, no, so it's x plus 2 and x minus 1. I will correct it in a minute, right? So x squared plus 2x, yes, it's minus 1. Very good. I got new whiteouts, my props. Okay. Very good. So then we have x equals negative 2 and x equals 1, and I have to plug them in to find the point. So y was 2x cubed plus 3x squared minus 12x and plus 3. And when I plug in negative 2, I also spilled water last week. I think I mentioned that to you, and I had to buy a new calculator because I damaged it. It doesn't work anymore.
Is your calculator covered in saran wrap?
Yes, yes. Because I just bought it. I just bought it, and I don't want water on it anymore. Oh my goodness.
Understandable. Okay.
So please be careful. You can drive a tank over it and it will not get damaged, but a drop of water will skew all the calculations. Yes, and I wrapped it up because I don't trust myself. That's what it is. So I have to punch in the function 2x to the third to 2x to the third. That's what I did. It just upset me very much. I'm very careful. I don't drink anything. I don't. So there shouldn't have been any problem, but that's what I did. So negative 2 and 1. So y is 23 when x is negative 2, and y is negative 4 when x is 1. So the points where the tangents are horizontal, which obviously represent max min, will be negative 2 comma 23, but that we don't know that. This is chapter 3, and 1 comma negative 4. So that was 4. So let's see what 5 is telling us. Yeah, we are asked to find the limit. It's a nice problem, but it really is otherwise a simple situation, because we know L'Hopital's rule and we can apply it. It will pop up in chapter 4, but we didn't wait till that, and I never do. I need it much sooner than that. So when you plug in, you get 0 over 0. Tangent 0 is 0, sine of 0 is 0. So then limit as t approaches 0, you differentiate the top. You get secant squared of 10t times the inner function prime. And sine 2t is prime is cosine 2t times the inner function prime. But when you plug in 0, this will approach, oops, I meant 1. This will approach 1, and this will approach 1, so the answer is 5.
What did you say the bottom approaches?
10 over 2. Oh, when you plug in 0 in cosine, it approaches 1. When you plug in 0 in secant, which is 1 over cosine, it approaches 1. Very good. Next question.
We do 13 from the old test?
Yes, of course. Let me just find it. Where is it? 13, 9, 10, 11, 12, 13. Find the differential of the function. Yes, of course. Page 4. Y equals x squared sine 8x. Let me refresh your memory. Y prime is y prime, but dy, which is the differential, is y prime dx. So that's all I have to write. dy equals, I have to use the product rule and put dx. It has to be a sum. The first function prime is 2x times sine 8x plus first function times cosine 8x times 8, the inner function prime.
Can you repeat that all, just like what you have in the brackets one more time? It's kind of messy.
Absolutely, it looks squeezed in. dy equals, the first function prime is 2x times sine at x plus x squared. I differentiate sine, I get cosine 8x times the inner function prime, which is 8. I could just simply factor out 2, but there is no need. 2x, actually, you could. So 2x if you want, and you have sine 8x plus 4x cosine 8x and dx. But there is no need really for this particular situation.
Can we go over number 14?
Yes? What does it say?
Use differentials to estimate the square root of 100.4.
Very good. So the square root of 104? No, 100.4. Yeah.
100.4.
Yeah. It has to be, dx has to be. Okay. So remember, this is the same thing with f of x plus f prime of x dx. I have to identify each. So obviously the function is the square root of x. X is obviously 100. Dx is obviously 0.4. F prime of x is 1 over 2 the square root of x. So I have to put all these in. So f of x is the square root of 100, which is 10, plus f prime of 100 is 1 over 20, and dx is 0.4. And no, we're not asked to put this in the graphing calculator or in the calculator to get an approximate value. We're not. So here I have 10 plus, multiply top and bottom by 10, so we get 4 over 200. And simplify by 4, so this is 10 plus 1 over 50. That's all you are asked, so 50, it's 500 plus 1 over 50. So that's what you have to write. That's it. But yes, of course, I will take the calculator. Hopefully I don't spill water on it anymore. And I check my work, of course. So the square root of 100.4 is whatever, and 501 divided by 50 has to be whatever. And they have to be very close. And they are. One is 10.01998 blah blah blah, and the other one is 10.02. And they're very close. So basically what this is doing is linearization of the square root around 100. And that's what we get. This is a linear function approximating the square root function very close to 100. That's all it's doing. Very good. Next question. Anything else?
We also do 12.
Yes? Any questions on this before we move on to 12? Okay, I'm on page 5. And you said 12. 12. Where are you, 12? Nine, 10, 11, 12. Oh yeah, find the linear approximation of the function. So f of x equals the square root of 4 minus x at a equals 0. So it's the same thing, really the same thing. So it's f of 0 plus f prime of 0, x minus 0. F of x. Do not write f prime, please. F of x. Very good. So I have to find f prime of x, which is 1 over 2 the square root of 4 minus x times the inner function prime. So this is negative 1 over 2 the square root of 4 minus x. And I will plug in 0 here in f prime because I need it. And then f of 0. F of 0 is 2. F prime of 0 is 1. This is 2 times 2 is 4, negative 1 over 4. So now I have the line that approximates the function near 0. And that is f of 0, 2, minus f prime of 0, times x minus 0, which is just x. And I'm done.
Could we also go over number 11?
Yes. Let's take a look at number 11. Where are you? 11. Is that the extra credit? Oh yeah, we did this problem in problem in class. It's done in the notes.
Okay.
Yeah, it's a major topic, so I try to cover all topics possible that I found in the book. Nothing that is super sophisticated. So like the cone situation and the particle situation and the kite situation and the ladder situation and the distance with the cars. So I try to cover as many different situations as possible. Yeah, this was done. I can do it again if that's what you want.
Did we do it last class or the class before? Just so I know.
No, the last class where you started chapter 4.
Yeah, but we also had questions.
The previous one.
Class.
It was the previous one.
Okay.
It's in 3.9, so when you forgive me 1 second, Gia. It's in 3.9, so if you go back where I label everything so you can find it easily, so and so do I. So it's in 3.9. Yes, Gia, sorry.
I have a question about 1. It's all the way back under number 1. Can you do L?
L. Let's go back to L.
Sorry, I don't know if you guys did or not. I had to leave the room really quick.
So y equals hyperbolic sine of hyperbolic cosine. So when we differentiate this, we differentiate hyperbolic sine, which changes into hyperbolic cosine of the argument, times the inner function prime, which is, I didn't have to put in parentheses unless we put all of them, so that doesn't need parentheses. So times the inner function prime, which is that. Anything else? There is no need. I mean, it's the same thing. I can put this one and make it clear that they're all the same now for uniformity. Anything else you would like to ask? Anything else you would like to go back to?
Can we go over number 9?
Yes. Number 7, 8, 9. Okay. So you just have to differentiate. So we have x of t equals 8 cosine t. So x prime is the velocity. So you get negative 8 sine t. And the acceleration is negative 8 cosine t. And now the measurement units. So find the velocity. So that's the formula. Find the position, velocity, and acceleration of the mass at time 5 pi over 6. So when t equals 5 pi over 6. So remember where 5 pi over 6 is. It's 5 times 30, so it's 150. So it has a terminal side in the second quadrant. So sine is positive, but cosine is negative here. And if you remember, I showed you that little table. I can do it again. Sine, cosine, and pi over 6, pi over 4, and pi over 3. Very easy to remember. This is 1/2, so this is 1/2. This is the square root of 3 over 2. This is the square root of 3 over 2. And these are the same. So when we determine sine of, we're not interested in this because everything is over 6. So we are interested in these two values. 1/2 on the square root of 3 over 2, but they may be negative. So the cosine will be negative here. So coming back to the distance, so x of 5 pi over 6 will be 8 multiplied by cosine 5 pi over 6, because this is the reference angle. I'm sure you remember. The reference angle is pi over 6. So this will be multiplied by negative the square root of 3 over 2. So it turns out to be negative 4 the square root of 3. Now for the measurement unit, x is measured in centimeters and t in seconds. So this is the distance, so it's centimeters. Now the velocity of 5 pi over 6 will be negative 8 and times sine, but sine of 5 pi over 6 is positive 1/2. So this will be negative 4, and this is centimeters per second. And the last one, the acceleration, a of 5 pi over 6 is negative 8 times cosine, but cosine is negative the square root of 3 over 2 with minus in front. So this will be positive 4 the square root of 3, and the measurement unit for acceleration is centimeters per second squared. It's the rate of change of velocity with respect to time. And in what direction is it moving at that time? So it all depends on the velocity. So because the velocity is negative, is moving in the negative direction. Because the velocity is negative. Any questions?
Can we do number 6?
We want to do number 6? You said?
Yes.
Okay, number 6.
Thank you.
Sure. Number 7, number 6, number 6. Yes, so find the equation of the tangent line to the curve at a given point. So I have y prime, which is 11, 1 plus 2x to the 10th power times the inner function prime. So this is 22, 1 plus 2x to the 10th power. And then I will determine this value when x is 0. When x is 0, I have 1 to the 10th, so this will be 22. So I have y minus y1 equals the slope times x minus x1, where x1 is 0, y1 is 1, and this is 22. So then y minus 1 equals 22x, because this is 0, or y equals 22x plus 1.